Okay, so for this next video, we're going to talk about the converse of the Pythagorean theorem. This is something that, or another use for the Pythagorean theorem that we can use to figure out some things about triangles. So say we are given a triangle, but we don't know the measurements of the angles or anything like that. And we need to figure out if it's acute, obtuse, or right. Okay, so just given the side lengths of the triangle, we can figure that out. Okay, so if all we know is the side lengths of the triangle, we can use the Pythagorean theorem to figure out what type of triangle it is. I know we can mostly just eyeball that, but sometimes we may not be able to see the triangle, especially when we're dealing with like construction and stuff like that. If we just know the side lengths, we can actually figure out those angles and stuff like that just by those side lengths. So one thing we can do is use the Pythagorean theorem. So you can probably guess this, but if you take the two sides and square them and add them together, and they're equal to that longest side squared, guess what? It's a right triangle. Okay. Again, that's pretty much the Pythagorean theorem in a nutshell. So if the two sides squared added together are equal to the longest side squared, it's a right triangle. Okay. If you take those two smaller sides and square them and add them together, and that total is less than the longest side squared, you know that that triangle is going to be obtuse. Okay, it's an obtuse triangle. It's like Mrs. Never. Okay, and then if you take those smaller sides, square them and add them together, b squared, and it is greater than that longest side squared. It's a cute triangle. Very, very cute triangle. Okay. So you can just, given what those side lengths are in comparison to the longest side, you can tell if the triangle is going to be right, obtuse, or acute triangle. Okay, so let's try this in action. So let's look at this first one right here. So I don't have to guess which one's the longest side. Longest side is obviously going to be the biggest number, right? So these would be my two legs. So I'm going to square them and add them together. 5.2 squared plus 33.6 squared. And then I'm also going to square this longest side over here. I'm not going to set it equal to or anything like that. I don't actually have to know if it is or solve it for anything like that. I just need to know how they compare to those two sides added together. So let's try it. 25.2 squared is 635.04 plus 33.6 squared is 1,128.96. Add them together, and you get 1,764. Okay, so that's the two smaller sides squared and added together. Now let's square 40. So 42 is also 1,764. So those two smaller sides squared added together are equal to the longest side, which means this is going to be a right triangle. So the answer is right. Okay, so that's one. Let's try another. Now I can probably tell what this is going to be just by looking at the triangle. It's a small acute triangle, right? But let's see the sides that the sides will verify for me. So longest side is going to be this one right here, right? 168.2. Actually, maybe it could be. I don't know. We'll see. All right, well, let's try 168.2 squared. That is the longest side. And I'm going to take the smaller side, 8.2 and square them and add them together. Plus 166 squared, so 8.2 squared is going to be 67.4. 166 squared is going to be 27,556. Then we add them together, and we get 2,763.4. Okay, so those are the two smaller sides squared added together. Now let's square our bigger side. So 168.2 squared is going to be 28,291.24, which means that side squared, the bigger side squared, is bigger. Okay, so it is not a cute triangle. It is obtuse. Obtuse triangle. Okay, so we can figure that out just by figuring out how these two sides squared and added together compare to that longer side squared and added together. And that's really all it is to it. If this side is bigger, it's going to be obtuse. If this side is smaller, it's going to be acute. If this side is equal, it's going to be right. Otherwise, it's, just using the Pythagorean theorem to figure stuff out.